All right, so welcome back. Welcome back to this YouTube channel. So in the last video, we have learned about LangChain. I have thought of continuing that series. Maybe making that. As you know, I have lost my ChatGPT API account because I have used that for a long time. So in this video, we are going to continue on with the new topic: generative adversarial networks. You might have stumbled upon some amazing websites, some and like that you can actually generate new photos, fake photos. The computers generate this image without even you animating, right? So even animations, you can do animations also, create generate animation frames, and also videos. I'm telling you, there are some researches going on. I can share some papers with you in the description, so make sure to check that out too. So there is a lot of development because of this GANs is nothing but generative adversarial networks. I'll break down the whole part in this video, the basic introduction, the basic introduction. In the next video, we're going to look at deep CNN GANs, and then we're going to look at different types of GANs also. So this is the paper, Generative Adversarial Nets by Ian Godfellow, John. I can't read the name, but these people, these very smart people have built this paper for us. We'll go through this paper. So before that, I just want to show you a sample website. I just want to show you a sample website in which you could actually see some images that are actually generated by GANs. You might also heard about DALI, like that is also a website where you can have text to image generation, where you can just put in some text and you can just get an image based on the text. You might also heard about that. But in this video, I'm going to show you a very basic website, very old one, but pretty good website, right? So the website name is this person does not exist. So every time you open this web page, you can actually see a very new photo, and this photo, to your surprise, this person does not exist. And if you could just like hit the restart button, and you'll get the photo of a new person, and this person does not actually exist. It's actually created by these very powerful generative adversarial network. So in this series, that we are going to cover that, how these networks work, like how can these complex relationships be learned, and some problems you might face, and hopefully we'll also build some projects like these. We'll definitely do that. So in this video, we will be learning about GANs, what are GANs, and how, like, why do we actually care, what are the developments, and hopefully just we can understand the um, very basic overall high level introduction. In the next videos, we'll go in the details, and we can also discuss some powerful networks like DALI by OpenAI, the same company that released ChatGPT. They are the ones who have also worked on many image to text to image models and all that. We'll be looking and going through them also. So what are GANs? So GANs are, as you might know from if you have learned about image classification, right? Right. You have models that can, given an image, the models can find patterns in this image, and can differentiate them, right? And can understand these images. You have learned about that, right? Image classification. So what are GANs is, will build the same models but way more powerful and way more complex, such that given the label, let's say one for let's say one for dog, or and zero for cat, let's say. So given a label, right, we can actually use model, like a model, and then we can actually generate the image. So that is the problem. So that is the problem we are solving using GANs. So the GANs should be able to use more complex layers, of course, because finding features in an image is way more easier than generating an actual image with those patterns. We need to have way more complexity, way more accuracy, because generating image is relatively harder. Because if we say, let's say you have a person and he does not know how a cat looks like, so teaching him how to differentiate between a cat and a dog is easier than teaching him to actually draw a cat, because like way more features should be recognized. So therefore, identifying an image is way more easier than actually generating it. So therefore, we want way more complex neural network with many more neurons, of course, with many more complexity. And we should also do one more big change. to this normal neural network. So how can we build this? How can we build this? So just like a normal neural network, let's say you are given a class, or you can just build a CNN, right? Just build a CNN with the input, let's say a class. Let's say you take class as input, and you can just have some, let's say, kernels, right? You can just have some random image and apply these kernels of this randomness and hopefully get to an image. So just have random images or random pixel, and keep updating these pixels in gradient descent. So that is a basic idea. You might say it will work, right? If you have like powerful systems and you can have just let's just have a CNN for each pixel and generate each pixel, it might work. You might say it might work, but the problem is, like, it is definitely not better, because the main problem we will be facing is the loss function. So this is actually a generative model. Based on the class, we could actually have a neuron for each pixel, right? We could do it for each pixel, and generate output, generate the pixel value for each pixel. Yeah, the model will be pretty complex, very complex, because we have many layers, and we should have many more layers, not just in the output layer, many neurons in the output layer, not just many neurons in the output layer, but we should have many layers in between, because to actually find the patterns, to actually get accurate image. But the whole problem is the loss function, right? How can we build a loss function? If you think about it, all right, let's say you have image of me, two images of me, right? Two images of me, maybe in different poses, maybe in different lightings, maybe in different areas, right? Maybe in different things, just like that. So how can we actually, let's say this is or let's say this is the model. So the model predicted this image of me. This is not a real image. This is the real image. This is the fake image generated by the model. So how can we actually differentiate, and how can we actually give the model a performance estimate of how good its prediction was? How can we evaluate the prediction of the model? So that is the main problem that will be that the early researchers have gone into. How can we actually do that? If you can think about it, you might say we could just use something like Euclidean distance or something. Just maybe subtract them off and maybe do that. But it will not work. It will definitely not work, because lightings change and positions change. Maybe in one photo I was like that. Maybe I was tilted. Maybe the pixels don't overlap. Like, definitely Euclidean distance will never work. MSC will never work. All the loss functions that you know about definitely doesn't work, because they are not just better estimates of the prediction or how good the prediction was. So therefore, they have gone into a very very subtle idea. I mean, you could stumble upon this idea. You could, if you think about it. But what we are going to do is we can just develop another CNN. We can have another CNN, right? We could have another CNN, right? Which could just take this image, fake image, each pixel, or each we could just perform a CNN on this fake image and predict how good it was. We can just get uh, or we can just get the model to actually predict if the image is fake or real. So let's say we give this image to this CNN, right? So we'll train another CNN, not just this. So this is the generator. This is called the generator. All this, so all this is called generator. So we are going to train another model, which is called as a discriminator. So whatever the image the generator predicted or generator have generated, we are going to take the image generated by generator, and we are going to make this model make this model predict if it was real or fake. So we want this model, this discriminator model, to predict if this generated image is fake or real. So that is a problem that we are solving. How can we do that? So if you think about it, it is actually a battle between these. So generator is trying to fool the discriminator. So I'm going to go through the generator loss function in just a minute. So I'm going to go through. So the generator loss function is going to be to trick the discriminator. So the generator want to trick the discriminator, and the discriminator wants to predict if the generated image is real or fake. Again, we're going to have a bunch of real images. We're going to train the model on train the generated model on these real images, and then we're going to get these generated models or fake images and pass them through this discriminator. So the discriminator will predict whether the image is real or not, and based on that, we'll update the generated weights, also the weights of this discriminator. So we'll have both this neural network trained simultaneously. So for most of the cases, you'll have the generator train first or the discriminator train first, right? And after that, they will train simultaneously, and based on they'll just keep like it's a constant war between these two language model between these two neural networks, and they will hopefully we will train the generator to actually predict realistic images. So that is the idea. I'm going to go through that again. So we're going to have a generator. It will generate an image, and then we'll just take this image to a discriminator. I'm going to draw G here, and then the discriminator is going to predict if it's real or fake. And based on this, we'll reward the generator if or the generator will have higher accuracy if the discriminator is fooled. Right? If the discriminator is not fooled, then the generator will have lesser accuracy. Will decrease the accuracy of generator. That is the idea. So in training, while training, right? So we'll have this generator, right? Like for example, you'll have a bunch of images. You'll have a bunch of images. So the generator will predict fake images, bunch of fake images also. So these are real images. Sorry. So we're going to have bunch of real images and bunch of fake images. So let's say these are real images and these are fake images. So what we're going to do is these are generated by model. These are generated by these are real images. So we're going to input both of these sets to this discriminator, and the discriminator is going to predict the class for each image. And based on that, we'll update the weights of generator and the weights of this discriminator. So that is the idea. That is the idea of generative adversarial networks to actually have this battle among this generator network and the discriminator network. And let's get to this paper. Like that is what I think is there in this paper, right? So to actually use a adversarial nets, right? It's a mini max game, they also say. So the generator wants the discriminator loss to be as high as possible, and the discriminator wants generator loss to be actually to be as low as possible, or the generator wants that its own accuracy to be higher. So these are the loss functions. We'll use a common normal we'll use binary cross entropy for the generator loss function, discriminator loss function. We'll use this loss function for generator to actually see if this. So based on the performance of generator, we'll update the we'll reward or punish. Reward or punish is not the right words, but we'll train this generator network weights. So that is the idea of GANs, generative adversarial networks. So, and there are many more applications. Just make sure to check them out if you are interested. Just try DALI if you want. And then there is stable diffusion. There is and there are many more networks. I'll probably share them in the description. I'll share the link of this website also. The person does not exist. Also, I'll share the link of this paper, research paper, and then some more additional resources if you are interested. So thank you for watching, and I'll see you in the next video. Right. And again, if I could get my hands on LangChain, I would probably continue LangChain. If not, we'll go through GANs. We'll learn about GANs, everything. There's a lot to learn. And thank you for watching, and I'll see you in the next video.